In this video, we want to prove that if a and b are positive numbers and if they're not equal to each other, then a plus b over 2 is greater than the square root of ab. And you might remember or have heard before that the quantity on the left is called the arithmetic mean, and the quantity on the right is called the geometric mean. So we're basically saying that given any two numbers, their arithmetic mean is larger than their geometric mean. Now this one is a little tricky because how do you get from, hey, these two numbers are unequal to, by the way, here's this relationship. So what we're going to do is, since the end result looks like it could be manipulated some, I'm going to start there. So I'm going to say a plus b over 2 is greater than the square root of ab. So through a sequence of valid steps, we'll see where we end up and see exactly which way it is we're supposed to go with this proof. So we're going to kind of make it look like we really know what we're doing when we didn't know where to start. So the first thing I notice is I have a fraction. I'm going to multiply both sides by 2. So the first step implies the second step. So I'm going to have a plus b is greater than 2 square root ab. Then what I'm going to do is I'm going to square both sides because that seems to be a valid operation. And what we end up with there is, just after doing some algebra, we have a squared plus 2ab plus b squared is greater than 4ab. Well, interestingly enough, we have like terms, so we should probably bring them to one side. So that's going to give me a squared minus 2ab, because I have 2ab minus 4ab. And now we're thinking, where do I go from here? Well, remember, the left-hand side factors into a minus b squared. Now that's interesting, because that's going to be the ticket. So over here, I'm going to say, well, okay, if a is not equal to b, we know that a minus b squared is greater than 0. So this tells me that I'm going to take everything we did on the left-hand side and we're just going to work our way back up to the result. So if that's true, this means a squared minus 2ab plus b squared is greater than 0. And here's where the trickery comes in. Who would think to add 4ab to both sides? Well, somebody did, obviously. So if we add 4ab to both sides, because before we subtracted, I'm going to have a squared plus 2ab plus b squared is greater than 4ab. And I can kind of see where this is going. The left-hand side can be written as a plus b, the quantity squared, and I'm not changing the right side yet. That's still greater than 4ab. Now here is where the fact that they're positive numbers comes into play. We haven't had to really consider that yet. When we take the square root of both sides, remember in normal algebra, when you take the square root of both sides, you have to incorporate a plus or minus. Well, here, you don't really have to worry about that because this is a plus b over here, and normally it would be plus or minus 2 square root ab. But since we're only considering positive numbers, we know that the end results, that we know that a plus b cannot be negative. So there's that. And now we're almost there. I'm going to divide both sides by 2. And there we have it. We have our result, and we have the proof in the direction we wanted to prove it. We started off with a not equal to b, and we ended up with this result with a little bit of help from doing some scratch work over here. So this over here is the scratch, and this is the actual proof right here. Okay, so hopefully that helps. It is a bit of a stretch as far as a proof when you're just learning how to do proofs, but this is just kind of a sampling, a flavor of some of the types of proofs that we could run across in this course. So the fun part about this is it's not just about the results, it's about how we come up with these results. It's kind of interesting. So hopefully you found this helpful. I thank you so much for watching, and stay tuned for more proofs.